Hello everyone, so let's study first normal form. What does first normal form basically say? First normal form basically disallows multi-valued attributes, composite attributes and a combination of them both. So whenever you see a relation schema in which it is mentioned that it has multi-valued attributes, any attribute that is multi-valued or any attribute that is composite, you can straight away say that it does not fall under first normal form, or it does not satisfy the first normal form, or the relation schema is not in first normal form. Okay, for example, if you see this example relation schema, department, if you see this attribute D locations, it has more than one values for one particular tuple. Okay, so for one department name, it has multiple locations, right? And D locations is a multi-valued attribute, right? So this does not fall under first normal form. So you can directly say that this relation schema is not in first normal form. Also, first normal form now falls under the formal definition of relation in the flat relational model. So whenever it is explicitly mentioned that it is a relation, or it follows the definition of relation in the flat relational model, you can completely figure out that that particular relation schema is in first normal form, because a relation by the definition itself does not allow multi-valued or composite attributes or their combinations. So what is it trying to do? It is trying to disallow relations within relations, or relations as attribute values within relations. Okay, so with first normal form we can avoid those situations, and we can make sure that our relation schema only contains atomic and simple values. So what does it state? What is the formal definition of the first normal form? It states that the domain of an attribute must only contain atomic values, and that the value of an attribute in a tuple must be a single value from the domain. Okay, what does it say? It states that the domain of an attribute must only include atomic values, that is simple indivisible values, and that the value of an attribute in a tuple must be a single value from that domain. So now when it is saying that the domain should only include atomic values, then it means that the domain cannot include composite values, right, with the smaller component attributes or values. Okay, and it should be simple. Okay, so it cannot be composite, and it should be indivisible. It should not be able to divide into multiple components. Okay, and then the value of an attribute in a tuple must be a single value from the domain of an attribute. That is, the value of an attribute in a tuple must be a single value from the domain. That is, multiple values should not be allowed. Okay, so if you say see this particular relation schema, what is it doing? It is having multiple values. It is not following this particular rule. Value of an attribute in a tuple must be a single value from the domain. It is having multiple values from the domain. If we consider the domain of this particular attribute as the set of all locations, then this particular tuple is containing multiple values from the domain of the attribute. That's why it is not in first normal form. Okay, so, and it is actually not even called a relation. Okay, it is not even called a relation from the relational model point of view, and we have already seen, right, earlier when we were mapping ER model to relational model, how to take care of multi-valued attributes. So we do not allow these kind of attributes in the relation. We deal with it separately. Now let us talk about how to deal with these particular attributes. How can we actually deal with it? So how can we remove this? So we have already made sure that it is not in first normal form, because it is multi-valued attributes, right? So for each tuple there can be multiple values for the relation, so this is not allowed. Now let us see how we can break. So there are three ways in which we can break it. So one way is to have another relation with department locations like this, and have the primary key of this particular relation, that is D number here, and also have this D locations, and for every tuple, for every distinct value of the department location, have a distinct tuple in this particular new relation. Okay, which means that for every value or for every distinct location here, like let's say this is one location, so have one tuple. For another location, have another tuple. So what we are doing for department number 5, we are having separate tuples for every location. Okay, so what we are doing for 5, we have Bel Air, and for 5 only we have also Sugarland, for 5 only we have Houston, right? So each location is now coming as a separate tuple in the new relation. Okay, and then 4, for 4 only one value is there, so 4 has Stafford and 1 has Houston, right? So this is the This is how we can decompose the relation schema. And with this particular, and for this and if we decompose this, and if we remove this particular attribute from the this particular relation schema, we are left with only these three attributes here. So we will split this entire relation schema into two relation schemas, one which has these three attributes as it is, and one which is this relation schema. Okay, so this is the first method how we can break it into, or how we can make it the relation schema into first normal form. Okay, how we can decompose the relation schema for it to follow first normal form. Now let us see second method. What we can do apart from this? We can have, in this original relation only, we can have a separate tuple for each of these locations. Okay, what I mean to say is, let's say here only, if I say Bel Air, Stafford. Okay, here only I have one for Bel Air. Okay, and then here I put research again, and I put 5, and I put the same 3, 4, 5, 6, 7, and put the second location which is Sugarland. Okay, and then research 5, and then Houston. Now if you see this in this resulting relation schema, that is, we have modified the original relation schema. We do not have multi-valued attributes. We have skipped the multi-valued attributes. Now it is simple atomic values. Okay, so what the first normal form says that the attribute values, only attribute values allowed are single and atomic values. Now if you say in this relation schema and this attribute only has single indivisible values. Okay, and not composite or not multi-valued, right? So we have successfully converted it into first normal form. This is the second way. Okay, but what is the problem with this particular approach? Can you tell me what is the problem? So the problem with this particular approach is the redundancy, right? If you see the same information we are repeating again and again, see, twice we have already repeated. Let's say if there were even more department locations, like every department had even more locations, so we will repeat the same information for multiple times, so it is causing a lot of redundancy. And let us say if we do not have just 4 attributes, if we have even more attributes, then for all these attributes also we need to repeat, right? So it is leading to a lot of wastage of storage space and just a lot of redundancy, which we do not want. Why we are doing normalization? We are doing normalization to minimize redundancy. That is one of the objectives of doing normalization, right? So if you are doing that, then it means that you should be able to reduce redundancy. This way redundancy is not reduced that much. In this particular first way in which we decomposed it, we took care of the multi-valued attribute as a separate relation schema, the redundancy is greatly removed because we are not repeating all this again and again, right? But here the redundancy is more, so this is not a good option. Now let us talk about third option. Third option is that, since if we know that how many maximum number of department locations a department can have, then we can split this attribute into those number of attributes. What I mean to say is, if we know that one department will have at maximum 3 locations, right? Then what we do? We split this D locations into 3 attributes: D location 1, D location 2, and D location 3. Okay, and then for this particular, and if we remove these 2 tuples, then we can have Bel Air, Stafford, Houston. But for these tuples, what will happen? We will have null values because they have only one location. So the problem with this third approach is the introduction of null values, which will cause issues in querying the relation schema later. So we will also not follow this particular approach. So the first approach is the best approach. What it does is it takes the multi-valued attribute and it will create a separate tuple in the new relation for every value of that multi-valued attribute. Okay, so this is how we decompose the first normal form, decompose the relation schema into first normal form if it is already not in first normal form. Let us see one more example. Now first normal form also disallows multi-valued attributes that are themselves composite, that is nested relations. So if you see this particular relation schema, SSN is the key for this particular relation schema. Now if you see this particular, this is multi-valued attributes, right? If you see, we can see that this is the works on or projects relation. Okay, it is a works on relation. Okay, so what we are doing now, if you see this is a nested kind of attribute. So works on can be seen as a composite attribute which is composed of project number and the number of hours the employee works on that particular project. Okay, so this has multiple values and it is also composite kind of relation schema. So how do we decompose this particular relation schema? P number is also the partial key for the relation schema. Partial key means what? That for each particular employee tuple in this particular relation schema, this project number will have unique values. Okay, it's not like this particular, for this particular employee with this particular SSN and name John, we can have two tuples here with project number 1. So project number should be unique for each particular employee tuple. So that is the partial key. Okay, so now how we decompose it? We take this entire multi-valued this entire set of attributes as a different relation schema. So what we do? We create another relation schema. Okay, SSN, P number and hours. Okay, and SSN and P number together can become the primary key for this new relation, and then we can say 1 2 3 4 5 6 7 works on project 1 for 32.5 hours. 3 3 4 4 6 7 8. Sorry, not this. First we have to find out this only. First we have to take care of first tuple, right? Now it is working on also another project that has these numbers, that is on this project it is working for 7.5 hours. Then another project, sorry, another employee 3 3 4 6 7 8. Okay, and then 3 and 40. Then another 1 1 6 6 2 3 4, and then they are working on many projects, right? So for every project we will have a different tuple, right? 1 1 6 6 2 3 4 3 10, and so on. So now you see the redundancy is comparatively less. This anyways does not fall under the definition of relation. Okay, so you can directly look at it and say that it's not in first normal form. And whenever you can identify a relation, like a relationship like this, works on relationship or something like that, you create a separate tuple. Okay, you create a separate relation schema for this particular relation. Okay, for it to be so that it can be decomposed. So this is one tuple that we are making. Another tuple that we are making is SSN and email, or any other attributes. If they were there and normal attributes, then we would also include it here. Okay, and SSN is the key, and let's say these will be the tuple. Okay, John, and so on. Okay, so this is how we see how we break down the composite attributes. Let's say if we have an employee or a person, and the person has multiple car licenses and multiple phone numbers and also name. So what we do in case of this particular relation schema, this also does not fall under the first normal form. So what we do, we decompose it into two relational schemas. So first is car license, let's say name, or let's say some other Aadhaar. Okay, so Aadhaar will become primary key here, so also primary key here, and then car license. So for every multi-valued attribute, create a new relation schema, okay? And then one more, Aadhaar P number, okay? Number, sorry. So phone number it is, right? So when this is another phone number relation schema. Okay, so for multi-valued attributes, if we have multiple multi-valued attributes, this is how we decompose. Okay, this is how we decompose. We decompose it into more than one relation schemas, and this is how we decompose in case of composite attributes. Okay, if it is made of composite attributes, what we are doing, we are directly creating a new relation schema for it, and then we can have this. And if we know what is the partial key, then partial key and the origin and the primary key from the original relation are taken as the primary key for the new relation. Okay, and ours, right? So this is how the first normal form works. We will do questions about first normal form, second normal form later, but first I'll finish off second normal form. Also, I would highly encourage you to revise keys, candidate keys, primary keys. I have discussed it in the previous videos, prime attribute, non-prime attributes, because from second normal form all this becomes very important, because only if you understand what are the different types of keys, you can actually find out and you can actually decompose the relations and figure out whether they are actually in second normal form or third normal form or BCNF. Okay, so it is very important to understand keys for normalization. So do go through that video. Like this video if you like my content, and subscribe to this channel and press the notification bell. It will motivate me to make more videos. And yeah, I'll see you in my next one.